Give me a second. Yeah. So I solved the problem number 3 right there. Okay. So, and then I'm solving problem number 5. So I got the solution, negative 9 plus minus square root 36. But see, the square, what? Square root 36 is nothing but 6, right? You know that, right? Square root 36 is equal to square root 6 squared, right? This is equal to 6. Okay. So then plus and minus means that plus the square root 36 and minus square root 36. So that means the what? The equation has two solutions. Minus 9 plus 6 and then minus 9 minus 6. Minus 9 plus 6 is negative 3, right? And minus 9 minus 6 is negative 15. So, okay. So let me type the answer. Okay, negative 3 and negative 15. Okay. Now, next one. Yeah. Okay, so now next one, let's see, next problems. Next objective. So the completing square. Okay. So that was third method in the first objective, right? How to solve the quadratic equation. By using the completing square. Okay. Okay. So think about this. Let me give you an example. Okay. Okay. So x squared example. This example. I want to solve this x squared minus 24x. Okay. And then plus, I don't know, maybe 5. Okay. Equals 0. So I want to solve this. So then you may try to solve by factoring. I don't think it works. Okay. So, I mean, it can be, maybe it can be, you can find out factors. Okay. But it's not going to be easy. So, and then let me try to solve this one by using completing square. So here's strategy. The first one, we want to the rewrite. Okay. So, I mean, first one, we subtract 5. We just move constant to the right hand side. It means that we just subtract the constant term. So that we're going to get x squared minus 24x. Okay. So x squared minus 24x is equal to negative 5. And then now we're going to find the constant terms so that this going to be perfect square trinomials. Okay. So we did that. We have done, right, in the section of 1.3, right? I'm sorry, 1.4. 1.3, I'm sorry. So when we deal with the equation of circle, we learned it, right? So we find, so it's just step 1, now step 2. The constant. Get the perfect square trinomial. Okay, perfect square trinomial. Okay, so now then, well, how can you find the constant using what? The rule for completing square. Okay, keep in mind. So what's the rule for completing square? Remember that? So x squared plus bx plus b over 2 square is equal to x plus b over 2 square, isn't it? Remember that? So using this one, we can find out the constant term here. So here, x squared minus 24x, so b must be negative 24, right? Excuse me. So b is a negative 24, so we add what? Negative 24 over 2 square. Okay, but you have to do the same thing on the other side, right? So negative 5 plus negative 24 over 2 square, okay? Now that's going to be perfect square trinomial. Okay. And then, but by the rule for complete square, that perfect square trinomial should be factored as perfect square. So x plus b over 2. Here, b over 2 is negative 12, right? So x minus 12 square is equal to, yeah, so we calculate this one. You can, you can calculate this one using calculator. So let me use calculator. So negative 5, I mean, actually, yeah, so there, so 5, I mean, negative 5, right? And then plus negative 12 over 2, which is negative 12, right? So negative 12 square is 144, right? So we got 139. Okay. Now then what? So and then step, you can say this is step 3, but yeah. So in the step 3, we use square property. Okay. Use the square property. Okay. To isolate x. So yeah, we the square root just take a square root on both sides. So we're gonna get x minus 12 is equal to plus minus square root 139. Okay. Then x is equal to 12 plus minus square root 139. Okay. So the solution set what? So the solution set is what? 12 plus square root 139, then 12 minus square root 139. Okay. Okay. So keep in mind that, okay, step 1, uh, the isolate x square and the x term left hand side. Okay. Step 2, using the rule of complete square to find the constant term, so that we gonna get perfect square trinomial left hand side. Okay. And then what? Step 3, we use square property to isolate x. Yeah, I told you the complete square, this method is really, I mean, this is really a good, I mean, this is really powerful method. We can apply the complete square to any quadratic equations. Okay, that works for any quadratic equations. But as you can see that the process is quite complicated. Okay, you have to do a lot of work. There's pros and cons. So now next one, second. So let's see. Last one is the using the quadratic formula. Okay, let me explain this one and then see examples for the complete square and then quadratic equation, quadratic formula. Okay. So quadratic formula is quite simple. Let's say the quadratic equation is given as like this: ax squared plus bx plus c equals 0. Okay. So then here, okay. See. Then the solution must be minus b plus minus square root b squared minus 4ac over 2a. Okay. So yeah, it's I suggest you memorize this formula. Okay. So then it's gonna be really useful when you solve the quadratic equations. Okay. See here, plus, as you can see the plus minus sign right there, right? So the I told you quadratic equation has at most two solutions. Can you mind this? And then what if b squared minus 4ac is 0? Then that plus minus square root b squared minus 4ac is going to be 0. So this equation has only one solution, which is negative b over 2a, right? So what if b squared minus 4ac turns out to be negative? Then square root of negative number, that's going to be complex number, right? So this equation going to have the two imaginary solution, okay? And then what if b squared minus 4ac is a positive number? Yeah, then square root positive number is a real number. So the quadratic equation is gonna have two distinct real number, okay, real solution. Okay. So let's see example. Let's see example in the textbook. Okay. Let's see. So we're doing 1.5. Okay. Mm. Yeah. So this is example 3 in textbook. Okay. Uh, yeah, so question is this, solve each equation by completing square. So let me solve, I'm gonna solve the equation by completing square and by using the quadratic formula, okay? So first, let me do, let me see, let me do B, okay? Give me a second. Let me do A and B, okay, A. So the x squared plus 6x plus 7 equals 0. So now, by completing square, okay. So now, what are you gonna do? Step 1. So we subtract 7, right? So x squared plus 6x is equal to negative 7. Now step 2, what we using the root of completing square, we add constant, which is 6 over 2 square, right? Negative 7 plus 6 over 2 square. Okay. Now step 3, then that's going to be what? Complete perfect square trinomial. So it's going to be x plus 6 over 2 is 3, right? 3 square. The right hand side is going to be negative 7 plus 9, which is 2. So now then what? We are using the square property. We isolate x. Okay. So first we apply the square property, then we're going to get this plus minus square root 2. Okay. So from here to here, I use the square property, use the rule for completing square. Okay. Okay. From here to here, I use the square property. Okay. So then, yeah, and then last one, the answer is what? X is equal to negative 3 plus minus square root 2, right? Because I subtract 3. So the solution set is what? Negative 3 minus square root 2, and then negative 3 plus square root 2. Okay, you mind this? And now then, so you see that? So let me solve the same problems by using the quadratic formula. Okay. So let me do here. Okay, we have a space in here. Okay. Okay. So by quadratic formula. See, um, Now, when you when you use quadratic formula, please keep in mind this: you have to match uh, the given quadratic equations to this form. Okay, so for example, if the quadratic equation is given as like this, for example, okay, then you have to make 0 on the right hand side. I mean, you have to get 0 on the right hand side. You see that here, right there? You have right hand side, what, 0, right? Okay. So, but yeah, so fortunately, in these problems, we get 0 on the right hand side, so we just can figure out A, B, and C. Okay. So when you apply the quadratic, when you want to solve the quadratic equation using quadratic formula, you have to figure out A, B, and C, right? But to figure out A, B, and C, what? You have to match the given different quadratic equation to that form. Okay. So in this problem, A is what? The 1, right? And then B is 6, and then C is 7. Now, yeah, and then what? We plug in these three numbers into the formula. So X must be -6 plus minus square root B squared, which is 49, right? 7 squared is 49, minus 4 times A times C. I'm sorry, B squared is 36, right? Sorry. B squared minus 4 times A times C. So 4 times 1 times 7, 28, over 2 times A, which is 2, right? And then you simplify, you know, the quantity under the square root, okay? So that is equal to -6 plus minus, and then square root of what? 8, right? Over 2, okay? There. So now that what? Square root of A is a 2 times square root of 2, right? So this is a -6 plus minus 2 times square root of 2 over 2, right? Okay? And then I'm gonna ask break up this fraction as two fractions, -6 over 2 plus minus 2 times square root of 2. Okay, so then we're going to get -6 over 2 plus minus 2 times square root of 2 over 2, which is what? -3 plus minus square root of 2. So I got the exactly same answer as this. Okay, so using the quadratic formula, as long as you memorize quadratic formula, easily you can find our solution. But as you can see that you may need to simplify the fractions. Okay, it's maybe a little bit tedious, but quadratic formula is one of the most powerful method for solving quadratic equations. Okay, so you see, look at this. Compare complete square. Okay, that method is also working for any quadratic equations, but a little bit complicated. It's kind of long process, but quadratic formula, as long as you memorize the formula, yeah, you can find out solution. So okay, so now give me a second. So let's see. Mm, next one. So let's see a B. Okay, example. We see example 3. Okay, B. 2x squared minus 3x and then minus 4 equals 0. Okay. So by completing square, okay. Yep. Step 1. What we move the constant term to the right hand side, right? So 2x squared minus 3x is equal to 4. Okay. So now next one, I just add a 4. Okay. And step 2, Okay, so we use a root for complete square to get the perfect square trinomial on the left hand side. But here's the problem. So remember that root for complete square was, see, in the root for complete square, the leading coefficient, which is a coefficient x squared, is a 1, right? But in this problems, what, 2. So to apply the root for complete square, we have to make this one number to 1. So we divide by 2 the equation. Okay, so we divide by 2, which means the multiply by 1/2, but either one just fine. We're going to get x squared minus 3 over 2x is equal to 2. Okay, so to get this, I just divide by 2. Okay, so now then we use the root for complete square. So x squared minus 3 over 2x. Now keep in mind this here, this is b. Okay, that's the b. All right, so we add b over 2 squared. So negative 3 over 2 squared, okay, is equal to 2 plus negative 3 over 2 squared. Okay, so then that's going to be perfect square trinomial. Okay, perfect square trinomial. So then so that this can be factored as a perfect square, which is x plus negative 3 over 2, right? Which is a negative 3 over 4, right? So we got x minus 3 over 4 square. Okay. Now then that is equal to, the right hand side going to be what? So this is equal to what? 2 plus negative 3 over 4 square, which is the 2, okay, plus 9 over 16, right? So that is equal to what? 41 over 2. Okay. So we got 41 over 2. But you don't have to do like hand, okay? You can use calculator. So then step 3, then x use the square property, okay? So in x minus 3 over 4 is going to be plus minus square root 41 over 2. Okay. Now then x is what? It's equal to 3 over 4 plus minus. Okay. Give me a second. It should be, give me a second, not 2, right? I got wrong here. It's 4, 16. Yeah, it should be 16, right? 16. Okay, sorry. Because, yeah. So 2 is equal to what? 32 over 16, right? I just change it. Okay, adding that, combine those fractions, we got 41 over 16. Sorry. Okay, so now we're gonna get this square root of 41 over square root of 16. But square root of 16 is what? 4. So we got 3 over 4, plus minus square root of 41 over 4. So yeah, that's going to be 3 plus minus square root of 41 over 4. We can combine those two fractions because they have the same denominator, right? So, okay. So, I mean, solution, using the set notation, we can express solutions as like the solution set is like this: 3 minus square root of 41 over 4, and then 3 plus square root of 41 over 4. Okay, that's solution set. Right. So, yeah, let me skip solving this one using quadratic formula. Okay, so the next one, let's see one more problems having an imaginary solution. So let's see. Okay, so this is an example 4 textbook and problem B. Okay, so x squared minus 6x plus 11 equals 0. So what are you gonna do? Let's see. see. Okay. So now let me use the quadratic, solve this one using quadratic formula. Then, okay, then A, we have to check, find out A, B. We have to identify A, B, and C, right? A is 1, B is a -6, and the C is 11. Okay, so why? Because A is what? Leading coefficient, B is a coefficient X, and then C means constant. Okay, so then X gonna be minus B, which is a -6, plus minus square root B squared, okay, minus 4AC, okay, minus 4AC, -44 over 2A. Okay, so this is equal. Now we simplify numerator. Okay, so I mean the numbers on the under the square root. Okay, so 6 plus minus square root of negative 36 minus 44 is a -8, right? Over 2. So you see that here we got the negative number under the square root. It means that this is a complex number. Okay, so now that is equal to. First of all, let me just break up that fraction to. I mean, decompose the fraction to the two fractions. So 6 over 2 plus minus the square root of -8 over 2. So now, square root of -8, let me express this one using the complex unit. Okay, so here complex unit is what? I introduced this one the last time. Complex unit is I, that means square root of -1. Okay, so then this is equal to 6 over 2 is 3, right? The plus minus. Okay, now square root of -8, this is a square root of 8 times square root of -1, which is a square root of 8 times I, right? The square root of 8 is what? 2 times square root of 2, I. Okay. Square root of 8, I mean, -8 can be factored as 8 times -1, right? So we separate them. And then square root of -1, that's the definition of complex unit I. Okay. And then simplify square root of 8, we got 2 times square root of 2. Okay. So now I'm going to plug in this one into here. So then we're going to get 2 times square root of 2, I over 2. So 2, 2 cancel them out. So we got 3 plus minus square root of 2, I over 2. Not 2, just this one. Sorry. Okay. So this equation has two imaginary solutions. So solution set must be 3 minus square root of 2I over n, comma, 3 plus square root of 2I. Okay. Now, here's a question then. Can we figure out whether or not the equation has real solutions or imaginary solutions before solving the problem? Yes, the answer is yes. So as you can see that while we got, look at this, in this problems example, the reason that we got the complex and imaginary solution because the number under the square root is negative, right? If we got positive number here, then we would get what? Real solutions, right? So that one is what? B squared minus 4AC, right? So depending on sign of B squared minus 4AC, number of real solution, number of imaginary solution will be determined. So we say this is, we put new name for that one as capital letter D, okay? And then that is called the discriminant, okay? So we're doing, this is the second objective in 1.5, okay? Okay. So now then, so here we have think about three cases. D is greater than 0, and then D equals 0, and then D is less than 0, right? So case 1, case 2, and then case 3. Okay. What if D is greater than 0? Then if D is greater than 0, let me see. Oh yeah, here. If D is greater than 0, then you see that here. b squared minus 4ac is greater than 0, right? That's what that means. And then this equation has two distinct real solutions, right? So you can see that the quadratic equation. Okay, just get the quadratic equation has two distinct real solutions. Okay, so distinct two distinct real solutions. And if d equals 0, see that if d equals 0 means that b squared minus 4ac is 0. It means that that square root term will be gone. It means that plus the minus term will be gone. So negative b over 2a gonna be just solution. But that is a real solution, right? So quadratic equation gonna have just only one solution, one real solution. So if d is less than 0, we saw that. That's the that example, right? If d is less than 0, then the equation has what? Two distinct uh, imaginary solution. Okay, sometimes the textbook says that no real solution. But no real solution means that the equation has an imaginary solution. Okay, so keep in mind this. Um, mm, let's see example 5. Okay, so problem number C. Okay, so for x, here's a question. For each equation, state the value of the discriminant and the number of real solutions. Okay, well, let me do just see. So other two problems, A and B, yeah, please look at them. Okay, so see 4x squared plus 12x plus 9 equals 0. Okay, then the problem, doesn't ask you to find out the solutions. Just figure out the value of the discriminant and then number of the real solutions. Okay, so I'll solve problem C, and then you please look at the A and B by yourself. Okay. So here we have to figure out A and B and C, okay? A is 4, then B is 12, and C is 9, right? So now the discriminant is going to be B squared minus 4AC, right? So this is equal to B squared is 144 minus 4 times 9, right? Okay. So why we got the 144? Because B is 12. 12 squared is 144, right? Excuse me. So 4 times 9 is what? Let me use calculator. So 4 times 9, which is a 144. Okay. So that is 144. Okay. Yeah, 144 minus 144 is 0. So d equals 0. Okay. It means that this equation has one real solution. Okay. So the equation has one real solution. Okay. So how many real solutions does this equation have? One. Okay, what's the value of the discriminant? 0. Okay, so it's not a big deal, right? So that's the all about the 1.5. Okay. Okay. Let's see. Then we move to 1.7. 7. Uh, now, yeah, let me introduce 1.7 a little bit, okay, and then just go. Then let me stop. Okay, so 1.7. Oops. The linear and the absolute value inequality. Okay, and then AB absolute value. inequality. So here objective is this. Yeah, definitely we need to learn the inner notation. Okay, so inner notation. Okay, inner notations and inner things. Okay, so second one, open inner, close inner. So we're gonna learn the bounded inner and then unbounded inner. Okay, so that's all about the inner. Okay, so include the notation. Okay, and then open and close inner, and then unbounded inner. Okay. Oop. So now next one, yeah. So now we are gonna learn how to solve linear inequality. Okay, linear inequality. And third one, we're gonna learn the combined linear, inequality. Okay, so let's see, it's called the compound inequality. Compound inequality, nothing but two linear inequalities are combined. Okay, it's a couple. Okay, the last one is the linear inequality involving absolute value. Okay, so gonna be second. Mm, yeah, it's called absolute value inequality. Okay, so keep in mind this here. So now let me introduce the inner, okay? And then I'm gonna cover the linear inequalities, compound inequality, absolute value inequalities, okay? Next time, all right? So, but see, okay. So, but let me uh, take a roll first, okay? Okay, so now, so why do we need to learn the inner? Okay, so let me just give a simple example. X is greater than 1. I want to find out solutions of that linear inequality. Okay, so linear inequality is, okay, I think I need to explain linear inequality first. Linear equation with one variable, this, right? X plus b equals 0. That's a yeah, standard form of linear equation with one variable. So here, replacing the equal sign with by the inequality, because we can think about four inequalities, right? Less than, or less than, equals. Sometimes some textbook use that symbol, this one, okay, or, okay, but either one just fine, okay, but let me use this one, all right? So some textbook use this one, some textbook use that notation, but either one just fine, but I prefer to use this one, okay? So less than equals, greater than equals, okay? So replacing the equal sign with one of four inequalities, then that's gonna be linear inequality with one variable, actually. Okay. So now then back to that example, then how can you find out solutions? I don't think this inequality has one solution, because look at this, x is greater than 1. Then you know just 2 should be solution, right? Number 2. And then 3, 4, 5. Any real number greater than 1 can be solutions. So this inequality has infinitely many solutions. So normally, well, the linear inequality problems, since number of solutions should be infinitely many, infinity. So we have other tool to represent that kind of many solutions. So in mathematics, then so let me just express the that solution set of this one in number line. Okay, so it's negative infinity, the positive infinity. Okay, so here's a one, maybe 0. Okay, here's a 1. Okay, x is greater than 1 means that all of the numbers greater than 1, right? Okay, so then we use the inverse. Normally inverse notation has two, we use two symbol for inverse notation, parenthesis or bracket. Okay, here the parenthesis means that the, for example, the parenthesis means that the end number is not included in the solution in the inverse. For example is 1 comma 2. Okay, by the way, it's comma comma here. So this is not ordered pair. Do not confuse with the ordered pair. Okay, so that's the symbol of inverse. Okay, inverse here. So normally the left number must be, left number must, this is rule number 1. Okay, left number must be less than right number. Okay, we don't write inverse as like this. This is wrong expression. And then the parenthesis means that left to parenthesis means that left and number is not included in that inverse. So that means this one is set of all numbers between 1 and 2 except for 1 and 2. See that? Right and number, right, the what? The right inverse we use the parenthesis, right? So 2 is also is not included in that set. So that parenthesis is called the open inverse. Open inverse. It's open, right? Open. Then guess what? Close inverse, it means that here, the left and the number 1 is included in the set of inverse, okay? And then 2 close right there, that means right and the number is included in the set, okay? Is that bracket is called close, okay? Close inverse. And then this is close inverse, okay? But here's the question. What if I want to include the left and the inverse but not right and the inverse? Then we use this 1, close 1, and then open 2. Okay, it's called the half open inverse or half closed inverse. Okay, so half. Oops, half. Let me say half open. Okay, open inverse. Okay, so half open, or we can say half closed inverse. So keep in mind this: open parenthesis means and the number is not included. Close bracket means the n number is not included in the inverse. Okay, so now here, since back to this equation, example, x is greater than 1, x cannot be 1, right? So we have to exclude number 1 from the solution set. That means we have to use open through the what? Infinity. Okay, so I think at the beginning of this course, I told you infinity is what? Infinity is symbol, not a number. Okay, infinity just represents huge number what we cannot imagine. So we cannot include the infinity because infinity is not a number. So we got to use open again, actually. Okay, but in textbook they just use they don't mention any parenthesis or inverse notation. Okay, so the answer is what? Oops, this one through infinity. Okay, this is the solution set of that inequality using inverse notation. So in this section 1.7, yeah, definitely you're gonna deal with a linear inequality, but problems gonna ask you to write your answer using inverse notation. So you have to familiar with the inverse notation. Keep in mind this. So now then, we can think about so 4 cases, right? So for example, so right there. So one, I mean, so For example, 1 comma 3, and then 1 comma 3 close, and then close 1 comma 3, for example, and then close 1 comma 3. Okay, let's see. So this is open interval, right? So in interval notation, here is 1 and 3. It's open. Okay, right? So it means that what? The you can say using, yeah, so using expressing this one using x, using inequality, then you're going to get this. X is between 1 and 3. X is between 1 and 3, but not equal to 1 and 3. For this one, half open, right? This is opening number. This is half open. This is half open. This is closing number, right? Say opening number. This is half open. Half open. This is closed. Okay. Then 1, 3 is a 1 right there, and the close 3 means that x is between 1. I mean, x is greater than 1, but less than or equals 3 because close. Okay. And then half open right there, 1 is included, but 3 is not included. So 1, x is greater than or equals 1, and then less than 3. Okay. And the close is a 1 and 3. That means x is greater than or equals 1, less than or equals 3. Okay, keep in mind this. So now, let me stop here. Okay, so I'm going to continue to cover bounded, unbounded intervals, and then linear inequalities, compound inequality, absolute inequalities next time. Okay. So any questions, let me know, or send an email, or leave a message in the discussion board. Okay. So please understand that the finish early. Okay. So now, yeah, that's for today. Okay. So I'll post the lecture video in the Blackboard